For millennia, humanity stared into the ink-black night, transfixed by a persistent, blood-red spark that seemed to wander erratically across the stellar canopy. We named it after the Roman god of war, assuming its crimson hue was a testament to celestial violence. Today, the eyes of modern astrophysics have pierced that shroud of myth, revealing a reality that is infinitely more profound, tragic, and intimate. Mars is not a foreign anomaly. It is a mirror. It is a haunting, frozen monument to a planetary destiny that came terrifyingly close to mimicking our own. When our robotic Vanguard first descended upon the Martian regolith, they did not find a world that had always been a barren graveyard. Instead, locked within the rust-covered ruins of the Martian crust, we uncovered the chemical and geological scars of an ancient, vibrant Eden. 4 billion years ago, during the Noachian epoch, Mars was a world of roaring rivers, sprawling river deltas, and a massive northern ocean that held millions of cubic kilometers of liquid water. Its skies were thick with protective gases, and its core throbbed with a convective magnetic dynamo. It was a world entirely capable of birthing life. Yet today, it stands as a planetary corpse, stripped clean by cosmic forces. To understand Mars is to unravel a cosmic detective story, a narrative of how a sister world to Earth lost its global soul, and how humanity now prepares to cross the vacuum to resurrect it. The fundamental tragedy of Mars lies not in its distance from the Sun, but deep within its own internal anatomy. To maintain liquid water and a thick, life-sustaining atmosphere, a planet requires an active global shield, a magnetosphere. Earth possesses this shield because its massive size allows its core to remain a churning, convective engine of molten iron, creating a planetary dynamo. Mars, however, suffered the curse of its own dimensions. Possessing only about 11% of Earth's mass, Mars cooled at a catastrophic velocity. Roughly 3.9 billion years ago, the molten interior of the red planet began to solidify. The convective currents slowed, the internal dynamo stalled, and the global magnetic field collapsed into localized, weak magnetic pockets. Without its protective shield, Mars was left utterly defenseless against the relentless, supersonic torrent of the solar wind. High-energy particles from the Sun slammed directly into the upper Martian atmosphere. Data captured by NASA's MAVEN spacecraft confirms that the solar wind stripped away the Martian atmosphere at a rate of human face-scale loss, tearing away oxygen, nitrogen, and carbon dioxide molecules over eons. The atmospheric pressure plummeted to less than 1% of Earth's baseline. As the pressure vanished, the ancient Martian oceans could no longer maintain liquid stability. They boiled away into the vacuum or retreated deep into the frozen subterranean crust as vast sheets of permafrost. The vibrant oasis was flash frozen into a desert, proving that a planet's external habitability is entirely dictated by the structural health of its deepest core. Because Mars lacks the tectonic plate movements that constantly recycle Earth's crust, its volcanic history operates on a scale of terrifying structural magnitude. On Earth, Shifting tectonic plates move across stationary volcanic hotspots, creating long chains of relatively small volcanoes, like the Hawaiian Islands. On Mars, the crust remains entirely static, locked firmly in place over fixed mantle plumes for billions of years. The result of this geological stagnation is the Tharsis Bulge, a volcanic empire that defies human imagination. Dominating this landscape is Olympus Mons, a supergiant shield volcano so immense that its footprint could swallow the entire state of Arizona. Rising 26 kilometers into the thin Martian sky, its summit rises completely above the active weather systems of the planet, standing as a silent titan in the near vacuum of space. If you stood at the base of Olympus Mons, you could not see its summit. The slope is so vast and gradual that it would curve entirely over the horizon of the planet. Flanking this monster are the companion titans of the Tharsis region, monuments to an era when the Martian mantle erupted with enough basaltic lava to alter the planetary climate. These gargantuan structures are permanent monuments to a world that lacked the dynamic crustal recycling of Earth, freezing its most violent volcanic epochs into permanent mountain fortresses of stone. If Olympus Mons is the greatest mountain of the Martian landscape, Valles Marineris is its most spectacular wound. Stretching for more than 4,000 kilometers along the Martian equator, this titanic canyon system is a tectonic rift valley that cuts across nearly a quarter of the planet's circumference. Unlike Earth's Grand Canyon, which was carved over millions of years by the slow, erosive power of the Colorado River, Valles Marineris is a structural fracture created by the immense weight of the nearby Tharsis volcanic province. As the Tharsis supervolcanoes grew, their immense weight pressed down upon the Martian crust, ripping the planet's surface apart in a catastrophic tectonic failure. The cliffs of Valles Marineris plunge over 7 kilometers into the Martian dirt, exposing billions of years of layered geological history, like the pages of an ancient textbook. Yet, while water did not create this grand scar, it undoubtedly reshaped it. High-resolution imagery captured by the HiRISE camera reveals massive outflow channels, layered sedimentary structures, and recurring slope lineae along the canyon walls. These features indicate that during brief, violent climatic warming events in the Martian past, immense torrents of liquid water surged through these chasms, turning Valles Marineris into a roaring, high-volume aquatic highway that drained into the northern lowlands. Though no human foot has yet touched the Martian soil, Mars is already inhabited entirely by a sophisticated civilization of robotic explorers. For decades, these mechanical emissaries have executed a systematic, scientifically rigorous campaign to answer the ultimate question of modern biology. Did life ever arise outside of Earth? In Gale Crater, NASA's Curiosity rover spent years climbing Mount Sharp, analyzing layered mudstones that proved the crater was once a long-lasting, habitable lake system with neutral water chemistry, containing essential elements like carbon, hydrogen, oxygen, phosphorus, and sulfur. Following this path, the Perseverance rover descended into Jezero Crater, an ancient impact basin that once hosted a flourishing river delta 4 billion years ago. Perseverance has successfully gathered and sealed dozens of pristine core samples from these deltaic clays, structures that on Earth are exceptional at preserving biosignatures, the fossilized remnants of ancient microbial life. Alongside Perseverance, the Ingenuity helicopter shattered engineering limits by achieving controlled, powered flight in an atmospheric density that is less than 1% of Earth's, proving that human ingenuity can adapt to the constraints of alien physics. These rovers have confirmed the presence of complex organic molecules scattered across the Martian surface. The pieces of the puzzle are laid out before us. We are no longer searching for a habitable world. We are actively archiving the physical remnants of an extinct ecosystem. Humanity now stands on the shore of a new interstellar age. The exploration of Mars is no longer a luxury of scientific curiosity. It is the definitive proving ground for the long-term survival of human consciousness. By utilizing the exact technologies tested during the Artemis moon missions, our species is preparing to leap across the deep space void. The hurdles are unforgiving. Extreme radiation exposure, the physiological degradation of microgravity, and a Martian environment where the temperature drops to minus 140 degrees Celsius. Yet, the raw resources for human survival are already waiting for us beneath the red dirt. By mining the vast underground sheets of Martian permafrost, future pioneers will split water into liquid oxygen for respiration and combine it with atmospheric carbon dioxide to generate methane rocket propellant, establishing the first interplanetary refueling infrastructure. We are not traveling to Mars to escape Earth. We are traveling to Mars to learn how to breathe life into dead worlds. It is an unforgiving, generational struggle that will fundamentally transform our species from terrestrial beings into true citizens of the cosmos. Thank you for exploring the Solar System Chronicles with Science Odyssey. If you are ready to venture deeper into the infinite void, subscribe and join us for our next chapter, where we journey past the asteroid belt to confront the undisputed sovereign of our planetary system, a gargantuan, swirling storm world of liquid hydrogen, deadly radiation belts, and a court of ice-covered ocean moons. We are crossing the threshold to the king of planets, the gas titan, Jupiter. Thanks for watching.